Yeah, it is visible. You can go ahead with your presentation.
Thank you. Uh, Firstly, good evening, everyone. My name is Ayush Kumar Gupta, and today I will present my capstone project AI-powered care coordinator smart management for chronic health. This project focuses on improving chronic care management using AI agents. The goal is to move healthcare system from passive record storage to active patient coordination. So here's a quick agenda, what and all topic I will be covering across the presentation. And so the biggest problem is statement or the problem of statement what I've gathered so far is that the current healthcare system are highly fragmented and reactive. Doctors spend more time using EHR system than interacting with the patients. For example, a diabetic patient may miss an annual A1C test because the system only store records instead of proactively detecting the care gaps. Different hospital also uses incompatible data formats, making coordination too difficult to handle. This whole process will create a clinical burnout and delayed patient care. So we are trying to tackle these problems through our solution. So the biggest motivation was solving the reasoning void in the healthcare AI. Most systems today are stateless, meaning they forget patient context between interactions. For example, if a patient is allergic to a medication, that context can be lost during a specialist handoff. MCP AI introduced a persistent memory object that preserve patient history and reasoning state. So chronic the chronic diseases such as hypertension and diabetes require continuous monitoring and coordination. Traditional EHR system mainly function as digital filing cabinet. Modern AI techniques like LLM, FHIR, interoperability, and multi-agent orchestration creates opportunity for proactive healthcare management. Our system combines these technology in a unified coordination platform. So the previous research shows clinical burnout is heavily caused by administrative documentations. Studies also show multi-agent system perform better than single AI models under large clinical workloads. Another challenge is to identify in literature is converting unstructured doctor notes into a standard FHIR dataset. The project, so the basic idea of this project is to build on these findings by combining interoperability, reasoning, and automation into one system. So this is the particular synthetics matrix which we have compared major research paper with our proposed solution. So the contribution is integrating these concepts into a real-time care coordination agent. For example, instead of waiting for doctors to manually check records, the system actively monitors patient timeline and flags missed follow-up automatically. So in the features list, the traditional EHR system are passive and require manual searches. Our proposed system is active and state aware using MCP memory object. It proactively detect care gaps and alert provider in real time. So the approach we use is a distributed multi-agent architecture. Different agent will handle different roles, such as handling the ingestion or monitoring and reasoning and notification. These all agents will work independently. This separation involves scalability and reliability as well. We also use FHIR standard to maintain interoperability across healthcare system. So the architecture includes the React for the front end and the Fast API for the backend service. MCP AI maintains the longitudinal memory and reasoning context. Um, Specialized agents will process patient records, identify risk, and generate alerts. For example, if blood pressure reading remain above 140 over 90 multiple times, the reasoning agent triggers an alert automatically. So the UI focus on simplicity and fast access to patient insight. Providers can quickly view patient summary, alerts, and care gaps. Important information is highlighted proactively rather than buried inside records. So the dashboard provides you a view with reducing unnecessary navigation, and it has a manual chart reviews as well. So the wireframe demonstrate the intended workflow for clinical clinicians, and the key patient metrics are alerts and recommendation are centralized in one single view. So when it comes
Ayush,
down
sorry to
to
interrupt you. You have 5 more minutes left for your presentation.
got it. So when it comes to the design aspect, we have three basic endpoints wherein the patient denotes the patient registry, patient ID summary is wherein like your reasoning agent will comes into the picture, and the BP trends will show the real-time time series data, how the BP is fluctuating, and it will be connected to an IoT sensors as well. So here's the architecture diagram, and I've already discussed the front end part is being taken care by React, and the back end is a fast API and the Python-based AI services. And it has multi-agent orchestration handled different clinical tasks independently. This allows us to simulate a realistic patient histories without privacy concerns. So I use Cynthia generated synthetic patient records for data collection. The data set included chronic conditions like hypertension and diabetes. So I analyzed the data set, and it shows the data set has both male and the female gender data available, and the ethnicity was mostly leaning towards the white, uh, and the age distribution is the mean data what we are finding is around 45 44 years, or let's just say 45 years at an average. So the analysis, as you can see, the we have different type of hypertensions or the different type of conditions available in our data set. And when we see to the hypertensions part, like it's almost the 23% of our whole data set. So we will mainly focus us on those 520 records, 527 records, which is highly available in our Cynthia dataset. And when it comes towards the finding, I will go through the demo later on, but I would like to discuss the finding first. So the first finding was that multi-agent system achieve similar accuracy using fewer computing resources. Secondly, automation reduce clinical administrative work, and thirdly, the hypertension monitoring agent achieved a great accuracy in care gap detection. For example, patients with repeated high blood pressure readings were automatically flagged for follow up treatments. So, in conclusion, this project transformed healthcare system from passive storage system into active care coordination platform. The system successfully reduced administrative burden and improved proactive monitoring. Overall, the project validates the feasibility of intelligent healthcare system. And in future, right now for the MVP part, I've chosen hypertension as one of the field, but we can expand this to diabetes, heart failures, and more other diseases as well. Also, I would like to have better model integrated into the system, such as Meditron or any other medically supported models. Finally, the conversational voice SMS agent could improve patient follow-up and medication adherence. Here are some of the annotated bibliography. I'm not going to go into that because of the time crunches, but here are the some of the annotated bibliography and the references. I will quickly jump to the uh, demo part. So this is the dashboard what I've completed so far, and within this we have around 527 data patients which have hypertensions, and it has some risk associated to each of those, and we have filters. If I select any of the patients, it will have its summary generated as well as like what an condition the patient has already faced and the BP trend. So this is the data which I already got from the Cynthia data set for the BP trend. But later on, we can connect to the patient IoT device and it will work smoothly. And the alerts part, it will alerts the doctors like what and all the patient like the patient is currently going through or what medication the patient is currently going through, and the doctor would be aware to recommend next set of medications to those. So that's a basic task of my project. If someone has any question, I will happy to answer.
Thank you, Ayush. That was a wonderful presentation of your capstone project.
Thank you.
Ayush is open up for questions. Any of the guests or presenters have any questions, please feel free to ask. I think none of them have any questions. I would like to ask one question, Ayush. How do you plan to maintain the security standards since it's related to patient details and all?
Okay. So yeah, for that I've been using multi-agent architecture wherein like one of the part is the ingestion agent. What that ingestion agent will do is like it will collect all the records from all the hospitals in different data formats. But the agent work is to convert those data into FHIR format, and for our clinical dashboard, we are not taking any sensitive information as per the HIPAA compliant. Like we are not taking any personal information of the patient. Instead, we are just maintaining those records, which will be helpful for the reasoning agent to give reasoning for the patient, which will be available at the dashboard.
Thank you, Ayush. That answers my question. I